It begins with a flicker in a telescope, a tiny speck moving against the stars. At first it seems harmless, but as the data comes in, the numbers change. Trajectory lines shift, possibilities narrow, and suddenly that speck isn't just a rock, it's a threat. Asteroids have impacted Earth before, and they will again. This isn't science fiction, it's cosmic fact. The Earth exists in a dynamic solar system, constantly moving through a shooting gallery of space debris. Every year, new near-Earth objects, NEOs, are discovered. Some as small as cars, others the size of stadiums. And a few of them are on paths that bring them dangerously close to our home planet. We've been lucky. In 2013, an undetected asteroid exploded in the skies above Chelyabinsk, Russia. It was only 20 meters across, but it released the energy of over 30 Hiroshima bombs. The shockwave shattered windows and injured over 1,500 people. And yet, this object came from the sunward direction, a blind spot in our detection systems. It was a wake-up call for astronomers, scientists, and governments worldwide. What if the next one is bigger? What if it doesn't miss? Asteroid impacts are not just theoretical, they're woven into Earth's geological history. The Chicxulub impact, which caused the extinction of the dinosaurs 66 million years ago, was triggered by a 10-kilometer asteroid. But even much smaller ones can cause devastation. A 300-meter object could destroy a major city. A 1-kilometer object could trigger global climate effects. And yet, only a fraction of these threats have been identified and tracked. Thousands more remain unknown. That's why planetary defense has become a top priority for space agencies. Organizations like NASA's Planetary Defense Coordination Office and the European Space Agency's NEO Coordination Center are dedicated to monitoring the skies. Their goal: detect potential threats early, before it's too late. New technologies are emerging to help with this effort. NASA's NEO Surveyor mission, launching in the late 2020s, will place an infrared telescope in space specifically to locate hard-to-see asteroids, especially those approaching from the sun's direction. Ground-based observatories like Pan-STARRS and ATLAS continuously scan the night sky for moving objects. But identifying a threat is just the beginning. What happens if we find an asteroid on a collision course with Earth? That's where deflection strategies come in. The most promising so far is kinetic impact, literally smashing a spacecraft into an asteroid to alter its path. This was the goal of NASA's DART mission in 2022, which successfully altered the orbit of the asteroid, Dimorphos. It was the first time humanity changed the motion of a celestial object. A small step, yet a monumental achievement. Other ideas are more ambitious. The punched-gravity tractor concept involves flying a spacecraft alongside an asteroid, letting its gravitational pull gradually tug the asteroid onto a different path. There's also laser ablation, where concentrated beams of light heat an asteroid's surface, causing material to vaporize and push it off course. Nuclear options have also been considered, especially for large or short-notice threats. But they remain controversial due to political, technical, and ethical challenges. The key to all these strategies? Time. The earlier a threat is detected, the easier it is to divert. That's why early detection is everything. Despite the seriousness of the threat, it's important to maintain perspective. Earth is hit by small asteroids all the time. Most burn up in the atmosphere. The real danger comes from the rarer, larger objects. And while the odds of a major impact in our lifetime are low, the consequences are so high that preparation is essential. The silver lining is that, for the first time in history, humanity is no longer helpless. We have the tools to search, track, and potentially deflect asteroids. It's one of the few natural disasters we may be able to prevent if we take it seriously. But the work is far from done. Thousands of medium-sized NEOs, those between 140 and 300 meters, remain uncharted. These are the most concerning, as they are large enough to cause regional destruction, but small enough to slip through current detection nets. Public awareness is also critical. Events like Asteroid Day, held annually on June 30th, the anniversary of the Tunguska event, aim to educate the public and encourage global cooperation on planetary defense. Because protecting Earth isn't just NASA's job. It's a responsibility we all share. At Infinity Beyond, we believe knowledge is the first line of defense. By understanding the risks, the technology, and the science behind asteroid tracking and deflection, we empower people to support this crucial work. After all, we only have one Earth. Imagine the day we spot a real threat. Imagine the countdown, the calculations, the mission, the tension as a spacecraft races across the void. Then, impact, deflection, success. A moment where humanity saves itself, not with panic but with preparation. This isn't just a dream, it's a mission in progress. Stay with us on An Infinity Beyond as we explore how science, space technology, and global collaboration are rewriting the rules of survival in the face of the asteroid threat. Because the sky is watching, and now, so are we.